Hi guys, Tin Man again. Something a little different away from the pulse motors. I was reading a little bit on single wire electrical transmission, so I thought I'd have a bit of a play around with it myself. What I've got here is just a little circuit out of a 12 volt fluro camping light. That's not actually on at the moment, there's nothing hooked up to it, as you can see. I modified it to pulse a little bit quicker, put a smaller cap on it and a lower resistor, which made it work a whole lot better. So we've just got our one high voltage wire coming out of that, going into here. As you can see, one wire going across. So our plan is to pump these three caps up, charge this battery, run this fluro, and we've got 1 and 2, 3, 4 neons, 110 volt neons. Now I found without them between the diode and the wire, the caps would charge very slowly. So I've got diode facing towards the positive and another diode in the right direction off the negative, going through the neons and then up to the single wire. And now single wire at the back, I've just got this little thing on there to hold it nice and tight. Here we've just got just a bunch of copper wire off one of my old pulse motor coils. I've got another neon there onto there. I've put this on here because it makes the battery charge a whole lot better. Now the battery is not a rechargeable battery, so it's not going to like it very much, but that's all I've got. Each one of our meters at the back is for each one of the caps. 1.6 volts, 1.1 volts, 1.1 and 0.825 volts in those caps at the moment. Our battery has 8.2425 volts in it. Our power supply is set at 4.3 volts, which is just going to the, of course, our negative and our positive wire, going through our unit and then into our one single wire. And like I said, these ones here are going to hook up to the light. So that's the plan. Off of one wire we're going to charge up the three caps. They're upside down, but 400 volt, 450 volt, 470 microfarad caps. So not a bad size. That's pretty much all there is to it. So we'll plug her in now. I was going to put this thing on the stand, but I can't get everything in the picture if I'm not holding the camera, so we'll plug it in. As you can see, we've got 1 neon, 2 neons, 3 neons, 4 neons. Now this one up here is lit, even though it's not hooked on or anything, it's just plugged onto the plastic, and it goes. Okay, you can see the voltages in our caps are climbing. Now I've noticed the middle one's a bit lazy. The end one's not quite as bad, but the first one seems to charge up the quickest. Now I'm not sure if that's got something to do with having the battery next to it or not. This battery's not actually hooked up at the moment, only to the voltage meter, but the neon's still glowing. So what I'll do now is going to plug one end of our light onto the back of our single wire. As you can see, our lights come on. Now out the other end of the globe, as you can see, if I touch the other terminal, she goes nice and bright. But at the other end of the globe I'm going to plug onto the positive here. So we'll do that now. And there goes our battery charging away. Our light's fairly bright, but what I'm going to do now is this one here that's hooked up to our roller mess. I'm also going to plug onto the back here, and that's the battery voltage. Goes up again and our light goes brighter. Our little neon that's just hooked to this roller wire is thumping away. So at the moment we're running that neon, that one, that one, that one, and that one's nice and bright. It's charging the battery, and our voltages in the caps are going up. Now the interesting thing is taken it's got some bite in it. We're drawing 370 milliamps at 4.3 volts without the battery hooked up. If I hook the battery up right now, our amp draw goes down, which is really interesting. And I found that each cap I was testing, every cap I put on, the amp draw would go down and down. It was around 460. It was just the one cap on it. And the more I put on it, made no difference to the charge rate, but brought the amp draw down. So that's our little single wire charging up those caps, charging up our battery. Lighting neon up there, there, and there. Just off of one wire. There's no other wires. So, well, that's pretty cool. Left long enough, those caps will go up to about 140 volts. So that's pretty good. So there you go. Is it possible to charge caps, run lights and everything off one single wire? It most certainly is. Oh, and charge batteries. And there's the timing out. So there you go, guys. One single wire, charging all those caps, charging the batteries, running 510 volt neons and a fluoro tube as well. One single wire. Cheers from the Tin Man.